All right, welcome back to another video with Aman. So in this video, we're going to just continue the topic of derivative. Well, in this lesson, I hope that we can just cover everything regarding to derivative in this book, which is grade 10's book. Okay, so regarding to derivative, we reached actually the rule of tan, and we explained everything about it. But there are some type of questions regarding to sine and cosine that they are among the exercises of the book, but it didn't give us like the specific rule about it. Okay, so the rule regarding to these kind of questions are just giving here. I just prepared by myself. So there are two important rules regarding to sine and cosine. The question is, what if we have what if we have f of x equals to, recently, remember we had sine 5x. So easily we said that derivative of this one, derivative equals to 5 multiplied by cosine 5x. Okay, 5 times cosine 5x. But right now, the question is, what if there was a function in the angle of sine and cosine? And imagine if f of x equals to sine, let's say, square root of 2x minus 10. Okay, what we are going to do to get the derivative of it, we are going to use this formula. We will say that take the derivative of inside this bracket, whatever is here, take the derivative of it. So derivative of square root, use rule number 5, it equals to f prime of x equals to, derivative of this one is equal to 2, just 2, over derivative of 2x, 2, derivative of 10, 0, no need to write it, over 2, the same square root, which is 2x minus 10. Put it inside the bracket, multiply by derivative of sine, cosine of the same thing, the same function, which is square root of 2x minus 10. This is how we take derivative for such a kind of function, when the angle of sine and cosine is a function itself. As well as for cosine of g of x, we have got negative g prime of x. Why negative? Because the derivative of cosine is with a negative. That's why, don't forget about this negative. So basically, we are going to say that negative g prime of x and derivative of cosine is sine gx. Teacher, please give us more example. Absolutely. So let's just go to the next slide. Okay, there is a table of examples regarding to sine. So f of x equals to sine square root of x cubed minus 2x. F prime of x would be derivative of here. So derivative is square root would be like rule number 5. X powered by 3 will become 3x2 minus derivative of 2x 2 over 2 the same square root x cubed minus 2x. Khalas, inside the bracket times derivative of sine cosine, the same thing, which is square root of x cubed minus 2x. That's it. How about derivative of f of x equals to sine this polynomial? Well, we're going to say that f prime of x equals to derivative of 5x2. 2 comes down, 2 times 5, 10, x powered by 1 less. So 2 minus 1, 1. Minus derivative of 3x, it is 3. Times derivative of sine, cosine, the same thing. 5x powered by 2 minus 3x. Okay, the last one. So derivative of inside, again, f prime of x equals to derivative of inside the bracket, so 2 minus derivative of 11 is a number, so derivative of number 0 times cosine, the same angle, 2x minus 11. This is how we are dealing with like such an example. Okay, let's move to the next example, next table, a table regarding to cosine's example. Let me see whether it is clear or not. Yes, it is. Well, derivative of f of x equals to cosine square root of 5x. Well, f prime of x equals to Derivative of inside the bracket. So inside the bracket we have got what? Square root of 5x. It's inside. So derivative of 5x, 5 over 2, the same square root, which is 5x. But please make a bracket here. Derivative of cosine minus sine. Please write this minus over there. Don't forget it. It should be in the very left side of the equation. So sine, the same thing. Square root of 5x. The next one. F prime of x equals to derivative of inside the bracket, x2, we have got 2x, 2 comes down, x powered by 1 less. So 2 minus 1, it's 1. Minus derivative of pi. My lovely student, derivative of pi is 0. Why? Because pi is a number. So close the bracket. Derivative of cosine minus sine, the same thing. X squared minus pi. Khalas. F of x equals to cosine x squared minus 3x plus 5. So in that case, we have f prime of x equals to derivative of inside that bracket. Well, we have got 2x minus derivative of 3x is 3 times derivative of cosine minus sine, the same thing, which is x2 minus 3x plus 5. I hope that by solving this question, the things are going to be obvious and clear, inshallah. So let's move to the next thing. I think the next slide is the last rules that we are going to have during this section. So last 3 rules. F of x equals to e powered by g of x. What was e? In chapter 4 we studied this function. It was called like natural exponential function. Natural exponential function. Now the question is, what if we have a function that it is equal to f of x equals to e powered by something, like g of x. This g of x is a general term that it can be any kind of function, okay? So in that case, derivative would be, take the derivative of the power. Always derivative of the power. Whatever is in the power, take derivative of it, multiply by the same function of e. The same function. Imagine if we have f of x equals to e powered by 3x powered by 6. Something like that. In that case, f prime of x would be, what is the power 3x powered by 6? By using the previous rules, we can understand that this 6 is going to come down. So 6 times 3, 18, x powered by 1 less, which is 5. Times the same function of e, which means e powered by 3x powered by 6. That's it. So take the derivative of the power, multiply by the function, or by the same function of it. The next rule is ln g of x. Again, we studied this one in the chapter 4. What was the inverse function of natural exponential function? It was natural logarithmic function, which is ln. So if we have f of x equals to ln g of x, the derivative is very interesting, just stay with me. Derivative is equal to, always take the derivative of inside this bracket, which is g of x. Whatever it is, take the derivative of it over itself. Yani g prime of x over g of x. How, mister? Like ln x powered by 2. So x powered by 2 is the angle. Derivative, okay, equals to, we know that x powered by 2, its derivative will become 2x over itself, which is x powered by 2. This x will kill one of these x's, so only 2 over x will remain. This is how we get the derivative and simplify it even. Okay. And the last and the most important one, in my point of view, regarding to derivative, is this rule. Let me just check the video. Okay. Perfect. So the last rule is f of x equals to g of x powered by n. Yani whenever we have a function powered by a number. Okay. For instance, what if we have f of x equals to x powered by 3 minus 2x plus 10 powered by 6, let's say. How are we going to take derivative of it? Recently, remember rule number 3, we had something like f of x equals to x powered by n. The base was only 1x. So we said that n comes down, x powered by n minus 1. we have the same idea, almost the same idea. Here, it equals to, the derivative would be f prime of x equals to n, which is the power, 6 times the same function powered by 1 less. So, x powered by 3 minus 2x plus 10 powered by 1 less. So 6 minus 1, 5. Times the derivative of inside. So x powered by 3 would become 3x powered by 2 minus derivative of 2x, it's 2. Derivative of 10, 0. No need to write it. That's it. Plus. There is no power over here. So you can just replace the place of these two. It's okay. 6 times derivative of inside the bracket times the bracket powered by 1 less. We have got multiple examples here. Don't be worried about it. Okay. And these two are not rules. It says that if a function consists of some different functions, its derivative would be equals to the derivative of each function individually. And if there is sum between them, if there is addition, so add. If there is difference between them, so find the subtraction between the functions. Okay. Take a look at this page. Yeah, everything is clear. So f of x equals to e powered by 4x. In that case, f prime would be, wait a second. I think that's better. Let me just check it, I guess. Okay, e powered by 4x. So f prime of x would be, we said that for natural exponential function, take the derivative of the power. What is the derivative of 4x? 4 times the same function that we have of e powered by 4x. Khalas. How about the ln x? It's somehow easy to memorize. Whenever you see ln x, derivative equals to 1 over x. Why, mister? Derivative of x? 1. We already studied it. Over itself, which is x. How about derivative of ln x plus 1? So f prime would be derivative of inside this bracket. Derivative of x, 1. Derivative of 1, 0. No need to write it. Over itself, which is x plus 1. Halas. 1 over x plus 1. No need to even put these brackets for that case. How about this, the last one? F of x equals to 2e powered by negative 7x. Well, this one is a little bit interesting. Be careful. F prime of x equals to, there is originally a coefficient 2. Rewrite it. Multiply by. Then start the derivative. So e powered by negative 7x. We said take the derivative of the power. Derivative of negative 7x, it's equal to negative 7. Multiply by the same function of e. E powered by negative 7x. Right now, can we simplify a little bit more? Definitely yes. 2 times negative 7, negative 14, e powered by negative 7x. Khalas. Okay, now before I solve this question, I want you to stop the video and solve it by yourself. Test yourself, see whether you can do it or not. Okay, I believe that you can do it. E powered by square root of x. So f prime of x equals to derivative of the power, derivative of square root of x, it's famous. 1 over 2 square root of x. How do you know it, mister? Derivative of x, 1 over 2, the same square root, times e powered by square root of x. Khalas. Derivative of, ln, if our function is equal to ln x cubed, so derivative would be x, 3 comes down, x powered by 1 less, which is 2, over itself, x powered by 3. Now, can we simplify a little bit more? Definitely we can. This x2 goes with 2 of these x's. What will remain? 3 over x. Halas. F of x equals to ln 2x plus 1. So f prime of x equals to, just change the color again. Okay, we said take the derivative of inside this bracket. Well, derivative of 2x, 2. Derivative of 1, 0. Don't write it. Over the function itself, which is 2x plus 1. Can we simplify, Mr. Yes, no, we cannot. because each one of these two terms should be, the coefficient must be divisible by these two. Is 1 divisible by 2? Absolutely not. So leave it like this. And finally, f of x equals to 5e powered by 8x. Originally, there is a coefficient, which is 5. Then start the derivative. Derivative of the power is 8x. Derivative of 8x, it is 8 times the function of e powered by 8x. So 5 times 8, 40 e powered by 8x. That's it. That's all about ln and e. I hope that it is understandable and clear. So let's go to this type of question. As I already said, that the last two things that I said, I don't consider them as rules. If a function consists of different functions, so we are just gonna take the derivative of each term individually. So we are gonna say that, okay, f prime of x equals to derivative of 3x squared. These two comes down. 2 times 3, 6x powered by 1 less, which is 1. No need to write this one even. Plus derivative of 5x, 5. Derivative of 1, 0. Don't write it. How about this one? F prime of x equals to derivative of sine 3x. Do you remember it's in form of sine ax? Rule number 6. We said that this a comes out. So 3 times 2, 6. Derivative of sine, cosine 3x plus derivative is 7x. It is just 7. Okay, and finally, derivative of cosine x, negative sine x. So there is a 3 here. So f prime of x would be negative 3 sine x minus. Derivative of e powered by 2x. Take the derivative of the power. 2. Why? Because derivative of 2x, it's in form of nx. So only n will remain, which is 2. 2 times the same function of e, which is e powered by 2x. Khalas. That's much easy. So don't think that that derivative is hard. Of course, there are like lots of rules, but when you practice a lot, you are going to get used to them. Let's go to the next slide. Again, a bunch of questions regarding to derivative of a function that consists of different terms. So 2x powered by 3. Again, derivative equals to 3 comes down. 3 times 2, 6x powered by 1 less. 3 minus 1, 2. Plus derivative of x squared, 2x. Derivative of 5, 0. Don't write it. F prime of x here equals to this 5 goes out. 5 times 3, 15. Derivative of sine, cosine 5x minus derivative 2x, 2. F prime of x equals to derivative of cosine 3x. This 3 goes out, so it's going to become a coefficient 3. Derivative of cosine, negative sine 3x plus, what is the power of the exponential function? 3x. Take the derivative of it, 3 times exactly the same thing, the same function of e. So e powered by 3x. That's it. That's all about derivative of exponential function, sine and polynomials. Let's just move to the next type of questions. Okay, the last and the most important rule that I said, a bracket powered by a number. A bracket powered by a number. So f of x equals to this bracket powered by 4. We said that f prime of x equals to, bring down this 4. That is 4. Derivative of inside. Derivative is 3x. 3. Derivative 2. 0. Leave it. Times the bracket itself. 3x plus 2 powered by 1 less. 4 minus 1. 3. Can we simplify more, mister? Yes, 4 times 3 it equals to 12. 3x plus 2 powered by 3. Khalas. The next one. F prime of x equals to 3 comes down, so 3. Derivative of inside, derivative is sine cosine x plus derivative e powered by x, it's exactly itself, e powered by x, note it down, times the bracket sine x plus e powered by x, powered by 1 less, so 3 minus 1, 2. I hope that it is clear. Okay, perfect. So let's just move to the next slide, the next two questions that again regarding to that bracket powered by a number. So f prime of x equals to 2 derivative of inside x powered by 2 2x plus derivative of 5x 5 times the bracket powered by 1 less, so x2 plus 5x powered by 2 minus 1, 1. Khalas. F prime of x here. Those students who are saying that derivative is hard, watch this video. 5 comes down, that is 5. Times, open this bracket please, derivative of cosine, negative sine x plus 2, write 2, rewrite it. Derivative of e of x, e powered by x, right before some minutes we said it. Derivative e powered by x is itself, so e powered by x times that bracket that we have, which is cosine x plus 2e powered by x, powered by 1 less than 5. So 1 less than 5 is equal to what? 4. That's all about it. That is a different type of question. Still it's derivative, but it says find the derivative of the function at the specified point. So it means that when we got the derivative, we need to find its value at this given point. Let's just do it. Okay, f of x equals to this polynomial at x equals to 2. First of all, find the derivative. F prime of x equals to derivative x3, 3x2. Minus derivative 2x2. Oh, when it comes here, so 2 times 2, 4x powered by 2 minus 1, 1. No need to write even this one. Plus derivative 4x, 4. So find the derivative at x equals to 2. You are going to say that f prime of 2 equals to 3, 2 powered by 2, minus 4 times 2, plus 4 equals to 2 powered by 2, 4, 4 times 3, 12. So the answer of here is 12, minus 4 times 2, 8, plus 4. So 12 minus 8, 4, plus 4, it equals to 8. So the derivative of this function at x equals to 2 equals to 8. That's it. The next function, okay, f of x equals to 3 sine 2x plus 2 cosine x at x equals to pi over 6. There are like 2 ways or maybe more ways to do this one. First of all, if you want to just stay away from pi, so consider pi as 180. Why? Because in trigonometry we said that pi equals to 180 degrees. So 180 over 6, you can say that x equals to 30 degrees. If you want to use calculator, so go in this way. X equals to 30 degrees. Great. So let's just find derivative. F of x, f prime of x equals to. These 2 goes out. 2 times 3, 6. Derivative of sine, cosine 2x, plus derivative of cosine, negative. Negative times this plus, minus. Again, I'm going to repeat it. Derivative of cosine is negative sine x. That's negative times this plus would be negative 2 sine x. Now the question asks, find the value of the derivative at x equals to 30 degrees. If you just go and enter, instead of x 30, use your calculator, 6 cosine 2 times 30, 60 degrees. Minus 2 sine 30. What it equals to? Cosine 60, it equals to 1 over 2. 6 times 1 over 2, it equals to 3. Minus sine 30 also is 1 over 2. So 2 times 1 over 2, it's 1. 3 minus 1, it equals to 1. So derivative of this function at x equals to pi over 6 equals to 1. Khalas. Next one. Again, there are 2 more questions regarding to this matter. Find the derivative f prime of x equals to 4 comes here, so 4x powered by 3 minus 2 times 2, 4x powered by 1, no need to write this one, plus derivative of 5x, 5 at x equals to 1. So substitute 1, f prime of 1 equals to 4, 1 powered by 3 minus 4 times 1 plus 5. It equals to 1 powered by 3 is 1. 1 times 4, 4. Minus 4 times 1, 4 plus 5. 4 and 4 are going to kill each other. Only what will remain? 5. F of x equals to sine 3x minus 4 cosine x. At x equals to pi over 2. What is pi? Pi is 180 divided by 2, it equals to 90 degrees. So instead of x, at the end substitute 90. So f prime of x equals to derivative of sine 3x. 3 comes out, so 3. Derivative of sine cosine 3x minus derivative cosine would be negative sine x. That's negative. With this negative would become plus, positive. Positive 4 sine x. 3 cosine, 3 times 90. So 3 cosine, 3 times 90, it's 270. You can just calculate it by yourself. Plus 4 times sine 90. It equals to cosine 270, it is 0. 3 times 0, 0. Plus sine 90, it equals to 1. 4 times 1, it's 4. 0 plus 4, the answer is 4. I hope that it is clear and understandable. The next thing, okay, there is a very important note here that we need to take care of it, because it's gonna become like a question. It's gonna come as a multiple choice, maybe. So the derivative of a quadratic function is a linear function. This part is itself can become a question, a choice, as a multiple choice question. The derivative of a cubic function is a quadratic function. Yes. In general, the derivative of an nth degree function is an n minus 1 degree function. This helps us to distinguish between the illustrative graph of a function and the illustrative graph of its derivative, just by knowing the degree of the function. In this part of the book, that's going to be the end, we are going to deal with like graphing the function, the original function and its derivative. Okay? Sorry. Okay. Let me just give you some examples. Sorry, the derivative of quadratic function. A quadratic function is something like 3x2 minus 6x plus 5, let's say. So let's just take its derivative. F prime of x would be 2 times 3, 6x, minus derivative of 6x, it's 6x. So what kind of function is the original function? Quadratic. What kind of function? Its derivative is like its derivative. It is linear. Why? Because the power is 1. That's why here it says that the derivative of a quadratic function is a linear function. The original function is quadratic, but the derivative is linear. As well as if we have f of x equals to 9x powered by 3 minus 2x plus 11. That is a cubic function. How do we know that? Because the highest power is 3. So its derivative would be f prime of x equals to 3 times 9, 27. X powered by 1 less. 2. Minus derivative of 2x, 2. Derivative of 11, 0. Now, the original function is cubic, but the derivative is quadratic. Why? Because the highest degree is 2. As well, like here it says that the derivative of a cubic function is a quadratic function. So in general, always, if you have a polynomial with degree n, its derivative would be with degree n minus 1. Yani if the degree is 9 of the function, if the degree of the function is 9, the degree of the derivative would be 8, 1 less. Perfect. Now let's come to graphing. Okay. Here it says draw the graph of the function and its derivative. Well, of course, there will be a coordinate plane over here. Okay, that we are already familiar with coordinate plane. Okay. So first of all, find the derivative, please. F prime of x equals to derivative of 3x, 3. Derivative of 1, 0. Okay. Draw the graph of this one, because what kind of function it is? It is a constant function. So f prime of x equals to 3. 1, 2, 3. So you can just say that that is the graph of f prime of x equals to 3. But how do we graph a linear function? The best way is to find the x-intercept and y-intercept. X-intercept and y-intercept. Well, in x-intercept, y is 0. So make y 0. 0 equals to 3x plus 1. Move this 1 to the other side. It's going to become negative 1 equals to 3x divided by 3 divided by 3. So x equals to negative 1 over 3. Negative 1 over 3. And for finding y-intercept, we know that in y-intercept x is 0. So 3 times 0, 0. Plus 1, 1. Plot these 2 points, connect them, join them, match them. It's going to give you the graph of this function. So 0, and let's consider this one is negative 1. So negative 1 over 3 would be somewhere around here. 0 and 1. 0 and 1 is here. So the graph would be something like this. That is the graph of f of x. To graph the constant function, just go and make a straight line on that number that the function equals to. To graph the linear function, the best way is to find the intercept. Then join these 2 points, plot them and join them. That's going to give you the graph. But what if the question was quadratic? How are we going to deal with it? Take a look at this one. Okay. Draw the graph of the function and its derivative. What kind of function do we have? Quadratic function. How do I know? Okay, let's just make a small change here. Let's just make this one 2. Okay, imagine here is 2. Okay, let me just do the change with black color. So let's just make this one 2. It can be 1 as well, but I want to have a beautiful example first, a simple one, and like stay away from fraction and decimal, this kind of stuff. All right. So first of all, please try to find the derivative. F prime of x equals to derivative of x2. We know that it's equal to 2x plus derivative of 2x. It equals to 2. So right now it's up to you. Either you want to draw the graph of this one or this one. But there is a note that you need to know it. We already said that to graph the linear function, we need to find the x-intercept and y-intercept. But how about to draw the graph of quadratic function? Remember, the graph of quadratic function were like in this way. It depends on the sign of the x squared. If it is positive, it's open up. If it is negative, it's open down. Okay, and we need to find this vertex. If you found this vertex, that's going to become easy to graph it. Okay. Remember this one in your mind. So, to find the vertex, at the end of chapter 2, we had something. We said that x of the vertex equals to negative b over 2a. So, negative b over 2a. Mr. Amanj, what is a and what is b? Remember here, the coefficient of x squared is a. The coefficient of x is b. The constant number is c. Okay, so let's just replace it. X equals to negative 2 over 2 times our A is 1. So 2 times 1, it's 2. Negative 2 over 2, negative 1. Whatever you got here for X, substitute it into this function to give you the value of Y. So negative 1, let's just substitute it here. Negative 1 power 2 plus 2 times negative 1 plus 2. These two are going to cancel each other. Why? Because 2 times negative 1, negative 2. It's going to go with this one. Negative 2 and 2, 0. What will remain? Negative 1 power 2, it's equals to only 1, positive 1. So the vertex, the vertex of our parabola, our quadratic function is negative 1 and 1. Here is negative 1, and let's imagine here is 1. So the graph would be something like this. That is the graph of f of x. But how about the graph of the linear function? Because our derivative function is a linear function. So in case if you want to find the graph of a linear function, we need to find x-intercept and y-intercept. In x-intercept, y is 0. Please don't mix it with the quadratic function. We are graphing this one, this function. It's a linear function. Okay? So if in x-intercept, fy is 0, so make this one 0. Let's say 0 equals to 2x plus 2. Move these two to the other side, so it's going to become negative 2 equals to 2x. Both sides divided by 2, divided by 2, divided by 2. X equals to negative 2 divided by 2, negative 1. That is the x-intercept. How about in y-intercept? X is 0. So make x 0. 2 times 0, 0, plus 2, 2. Now plot these 2 points. Plot them here. Negative 1 and 0. Negative 1 and 0 is over here. And 0 and 2. So here is 1. Let's imagine here is 2. So this is going to be the graph of f prime of x. That is how we graph quadratic function and linear function in the easiest way. To graph the quadratic function, go in this way. To graph the linear function, try to find the x-intercept and the y-intercept. Perfect. Okay. So right now there are 2 questions, 2 multiple choice questions over here. F of x equals to 1 over 2x powered by 2. Then what is going to be the f prime? Yani the derivative of this function. So for such a kind of function, we already said that f prime of x equals to this coefficient, leave it, and you rewrite it. Okay? Derivative of x power 2 equals to what? 2x. That 2 will cancel with these 2. So what will remain? 1 times x, x, which is option A. How about derivative of e powered by 2? A very beautiful example. E powered by 2 is a number. Derivative of number equals to 0. Don't forget about this point, please. E, whenever you see e and pi powered or multiplied by a number, derivative of it, still it's going to be 0 because pi and e are itself like numbers. Powered or multiplied by a number, still it's going to be a number. So derivative of number, it equals to 0. Perfect. One more question, and actually the last one, I would love to do it by myself. I mean, give you an extra questions regarding to graphing. Let's say, graph this function. Graph f of x equals to 2x2 minus 8x plus 1. Okay? And its derivative. And its derivative. Okay, that is going to be the last question regarding to the graphing. Okay. So first of all, we need to find the derivative. So let's just find it out. F prime of x equals to 2x powered by 2. These 2 is going to come down. So 2 times 2, 4. 4x powered by 1 less, which is 1. Minus derivative of 8x, it's 8. So that is the derivative function. Now, what kind of functions do we have? We have got a quadratic function and a linear function. For the quadratic function, we said to graph it, we need to find the vertex. So vertex was negative v over 2a. Negative v. b is negative 8. Negative 8, it's 8. 2 times 2, 4. 8 over 4, 2. Whatever you got here, substitute it here to get the y-coordinate of our vertex of the parabola. So, 2 powered by 2 minus 8 times 2 plus 1. 2 powered by 2, 4. 4 times 2, it's 8. Minus 8 times 2, 16 plus 1. 8 minus 16, it's negative 8. Plus 1, it equals to negative 7. Halas. Negative 7. So, if this is our coordinate plane, okay, x is 2, 1, 2. Y is negative 7. Imagine here is negative 7. So the vertex is going to come somewhere around here. That is the graph of our f of x. How about the graph of the linear function? Let's just do it together. So we need to find x-intercept and y-intercept. In x-intercept, y is 0. So make y 0. Come here. 0 equals to 4x minus 8. Move this negative 8 here. You're going to have 8 equals to 4x divided by 4 divided by 4. So x is going to be 8 divided by 4, 2. And how about y-intercept? In y-intercept, simply make this x 0. So 4 times 0, 0. 0 minus 8, negative 8. So 0 and negative 8. Halas. Plot these 2 points over here. 2 and 0. 2 and 0 is already here. 0 and negative 8. So if here is negative 7, here is going to be negative 8. So the graph would be something like this. That is the graph of f prime of x. The function itself is quadratic. The derivative is a linear function. So that's all about derivative in grade 10's book. I hope, guys, that you really got benefit from my videos, and thank you so much for watching me, for following me, for staying with me until the end of the video. Take care of yourself. See you in another video.